Hello students. In the previous video, we discussed on the effect of pressure on adsorption. There, we have explained the gases particles are adsorbed on the surface of solid. There are the process in which adsorption takes place from solution phase also. Let us discuss this. First of all, let us discuss some examples of adsorption from solution. First example, let us take litmus solution that is blue in color in a conical flask, which is shown in the first figure, and add charcoal in it. Then shake the solution, and then it is observed that the solution turns to colorless, which is shown in the second figure. Because the charcoal, which is a very good adsorbent, adsorb the colored particles present in the solution. That means the particles of the solution get adsorbed. Therefore, it is an example of an adsorption from solution. Let us take the second example. When the acetic acid solution is stirred with the charcoal, it is observed that the concentration of acetic acid decreases. That means some of the acetic acid get adsorbed on the surface of charcoal. Therefore, the solution which we are getting, it is have low concentration of acetic acid. Third example, as we know that the raw sugar solution, that is we are getting from the cane, sugar cane, is slightly pale yellow in color. We can decolorize it when we use charcoal. As charcoal is a good adsorbent, it adsorbs the colored particles from the raw sugar solution, and finally we'll get a colorless sugar solution. So that means the sugar which we are using at home are actually colorless. So this is the process which is done in order to make it colorless. So these are the examples. So now next discuss on the factors which is affecting the adsorb from solutions. The first factor is concentration. Adsorption increases with increase in the concentration of solute in the solution. That means higher the concentration, higher will be the adsorption. The second factor is the temperature. As in the physical adsorption, we discussed that adsorption decreases with temperature. Here also the extent of adsorption decreases with increase of temperature. Third is surface area. The powdered adsorbent are more readily adsorbed because they have greater surface area. So we can say that the extent of adsorption increases with increase in surface area. And this point is common in all type of adsorption, that is physical, chemical, and from solution also. Fourth one is nature of adsorbate and adsorbent. The extent of adsorption, it depends upon the nature of adsorbate and adsorbent. So after discussing the factor, now let us discuss the Freundlich adsorption isotherm for solution. This we have already discussed in the case of the adsorption of gaseous particles on the solids. Now let us discuss the adsorption isotherm for solutions. Here the plot we are making. In this, the plot is made between x by m, that is amount of the solute adsorbed, and with respect to C is the concentration. Look at here the difference. In the previous one, it is with respect to x by m by p, that is pressure. Here instead of pressure, because it is a solution, we will take concentration. So when we make a plot between these, it is observed that with the increase in the concentration, the x by m also increases. So we'll getting a line like curve like this, and after certain maximum value, it will be a parallel line. So let us discuss the mathematical expression for this one. So here x by m equal to k c to the power 1 by n. How we got this one? Because according to the plot, x by m is directly proportional to c to the power 1 by n. When we remove the proportionality sign, we'll get a x by m is equal to k c to the power 1 by n. What is x by m here? X by m is the amount of solute adsorbed by your unit mass of adsorbent, and C is the equilibrium concentration, that is in moles per liter. So this formula is nearly similar what we have learned in the cases of gases, but in the place of C it is P there, that is pressure. So that is the difference. So it is easy to learn both the formulas. The only thing is that you need to change the C instead of P. Now how to find the value of N and K? So as we have done earlier, we need to take logarithm. So take log on both the side. So when we take log on both the side for this equation, then we'll get log x by m is equal to log k plus 1 by n log c. Applying the formula of logarithm, we are getting the formula like this. Now when you compare this with a straight line equation, that is y is equal to mx plus c. What is y here? Log of x by m is the y, and x-axis, that is this one, log c, and c is the intercept, that is log k. So that means when after taking logarithm, we are getting a equation in the form of y is equal to mx plus c. That means when we make a plot between log x by m and log c, we'll get a straight line equation. So let us make a plot for this one. So when we make a plot for log x by m and log c, what we are getting? We are getting a straight line, because it follows straight line equation. So what is the equation which we have written? That is log x by m is equal to 1 by n log c plus log k. So from this is the y-axis, log c is the x-axis, and log k is the intercept. So we can say the intercept, this is the point where it is intercepting, that is log k. And here what will be the slope? 1 by n will be the slope for this plot. So same as it is what we have learned in the cases of gases, but the thing is that their pressure is taken, here concentration is taken, because in the case of solution we are taking concentration instead of pressure. So that is all about the adsorption from solution phase. So in the next video, we'll be discussing on the application of adsorption. Thank you everyone.